Hi, welcome to DCO. My name is David Capetti, and in today's video, I'll be sharing with you how to create this set of stairs. This was inspired from an image that I found online where you have this set of stairs on the right-hand side, the second floor, and you have this sweep that ties with it. I'll be going over all the steps in detail here, sharing with you techniques to create stairs. We'll be starting with creating a line segment, then the tread length, tread height, and then all the details you see here. I post videos like these every week so you can make advancements in your 3D modeling. Hopefully you find the stuff here useful. Make sure to subscribe if you like this content. And yeah, let's go ahead and get started. All right, so first thing we're going to do is I'll go here to units. I'll be using inches. And now that we have a new file here, let's start with creating a point. So let's double click here and go to construct, point. Now I don't have it previewed, but here we have that point. Now when we construct a point, it's by default going to be 0, 0, 0. Now we can use this point and route it through an empty point component so we can move the location. At this point, we now need to create the base geometry, which is going to be a line segment. So now we can take this point, move it in the X direction. Now we're going to give it the size of the stairs. So the width of the stairs are going to be approximately 48 for this design. Obviously we can change it with the slider. Now I'll take these two and I'll create a line segment between the two. So I'll start at the origin point, go to the end point using the point that I moved. So with these 2 points, we've created this line segment. Now this line segment we'll use to create an array in the Y direction. So I'll go here to move this line segment. In which direction? Well, in the Y direction. The way I know that is because if we look here at the bottom left, you'll see Y is in this direction, and that's the direction I want to move it, opposite of the length of the line. So we'll go here to Y direction, and then we'll give it a value of 12 inches. As you can see, we've only created one copy, and we need to create a series of copies of that. So the way that we do that is we bring in a component called series, which is a component that can create multiple numbers. The reason why we're not able to create multiple numbers is because this slider as an output only has one number. And the way to create multiple numbers is with this series component. As you can see, as the output, we have 10 numbers by default because it starts at 0. So it creates a series of numbers starting at 0, stepping by 1, and this is how many numbers you can create. So this series component itself creates multiple numbers, and by default, it's starting at 0, it creates 10 different points, and it steps them by 1. Well, now we want the step to be 12. So we want to start at 0, we want to step by 12, and we want 10. So we haven't changed how many copies we want, but we can also change how many copies we create here. Now as the output, different than what we have here with the slider, you see that it's only value of 12. Well, as the output, we have 15 values. We have 0, 12, 24, 36, 48, and they step by 12, and we have 15 values that go all the way to 168. Now that is what we use as the input because it creates all of those 15 numbers, routes them through the Y direction, and now we can create a series of copies that, number one, we can change how many copies we create. We can change how much it steps by, which this would be the tread length, and where it starts. So we can have it starting at, instead of at 0, we can have it starting at 1. but we don't necessarily have to do that for this design. So what we'll do is we'll take these, and now that we've moved them in the Y direction, well, now we need to move them in the Z direction. So I'll take it slow and show you how to take care of this. So we'll go to a move component and we'll take all of these and we're going to move them up. So we'll move them up in which direction? Well, if they're going to go up, it's going to be in the Z direction. Now, once again, we have the issue that if we bring in a slider of, let's say, 6.5, we're only moving all of those lines up by 6.5. So what we need to do is do 6.5 and create another series of numbers that change between 6, then 12, and so this is how we will do that. We'll copy the series component. We will make sure that the count is the same. We only want 9 numbers. Stepping by, so this is where we have the tread height, 6.5. And it starts at 0. So we'll go here to the series component. It says that we have 9 values, starting at 0, ending at 52, and stepping by 6.5. So the first one is 0, the next one is 6.5, 13, 19.5, and so on. In the same way that we did that to the Y direction, we'll do that to the Z direction. And notice that now we have created this sloped array of curves, and that's going to be our base geometry for our stairs. So with this, we've created a basic array of lines. Now we can disable the preview on this one, but first we need to take these line segments, and whether you want the slope on the right hand side or the left hand side, you would move them in that direction. So if we want the slope to be on the right hand side, we would move it in the X direction. If we want it on the other side, in the negative X direction. So I'll take these line segments, bring in a move component, the motion is going to be in the X direction, and I want it to go in the opposite X direction, so I'll bring in a negative. Now we can use a slider to move them to the side where I want them to slope. At that point, we can disable the preview on these because we don't necessarily need those. Now we have to take these lines and move them up to this location. How do we do that? Well, we have to go back, look at the Z direction. We know we have 6.5, and every time it steps up, it's 6.5. So if we multiply 6.5 by how many copies we've made, we can figure out the height, the overall height that we've achieved here. And it can always change because we have sliders, of course. So we need to mathematically tie it. So what we do is we'll go to 6.5. We'll go to multiply. So 6 times 6.5 times the count. So if you have 6.5 riser in the rise, then it's that times 8, and then we get the value of 52. Now we take these and we're going to move them again in the Z direction and plug that into the move. So now we can take the ones that were on the ground and we can disable the preview here. Notice that when we increase count, it will also increase the copies and the vertical height that we have different. Now I do see that it does go up past it, which means that this actually wants to be down here. So what we actually need to do is do 6.5 times this minus. So we need to subtract just one tread height. So we'll do minus 6.5, and we'll use that as the input. So all we did is we brought it down by one tread at the end. So now what we can do is we can connect. We have this and we have this, these two sets. Now we can connect them using, so we can also move this around. And if we did it at 40 or at the same amount as the stairs, then this would just be a straight line and you wouldn't really have any sweeps. So that's a critical mention here. Now let's go to the endpoints. So to connect these, we'll bring in the endpoints of this line segment, of those line segments, and these of these line segments. Now we're going to connect, if this is the start and this is the end, then this is the start and this is the end. So we'll go from start to end, and then that's how it'll go. So we'll go line segments, and if it's not that way, then we'll go like this. So start, and then the end of this one. And let's say that if those weren't the correct ones, I would actually be able to see that, they wouldn't be connected correctly. So a lot of this stuff you can visually double check. So now let's disable the preview on those line segments or on those points. Let's join these curves. So join curves is a component, plug them all in holding down shift. And now I flatten the input so it comes in an organized list. We have 48 values here. Now what we're going to do is take this and create the sweep here. Now, what's cool about parametric design is that we can use any slider. We can use chamfer, we can use fillet, but for this one we'll use fillet curve. So this fillet component we'll use as the input for the curve, and then the radius we'll do 1.500. Let's see if that works. We probably want a little bit more, so we'll go here, do 60. Here's what happens. The further out this comes, it actually starts going into a bit of your tread. So this is where we can go to the beginning and say, if this is too small, then maybe we can increase the length of it so it doesn't encompass so much of it. And also we can lower the fillet so it's not so crazy. So now I'll disable preview here and on these. Now we'll take these and we're going to turn them into solids. Now with this, you already have what you need in terms of the base geometry. Like we can just extrude. Let me show you that. We can technically just extrude these using the extrude component, curve as the input base, and then in the Y direction, we'll see that we're able to extrude it in that direction. But if this doesn't work, it's because we need to plug in the length of the tread. So it's stepping by 12. And we can use this 12 as an input. Now, for some reason, this is giving us some issues, and it's probably when you do the fillet, like, oh, I know why. Because there's a top tread here that is actually not using the fillet. And the reason why is because it's a straight line, but that is actually where your last tread would be. And so that is what's causing the issue, is that you can't fillet the edge of a curve that is straight line. And then here, when you extrude it, it won't extrude that last one out. So one way to fix that, okay, is getting rid of this. If I just kind of go here, it'll work, because this would be the last step until you hit the floor. So this could in some ways cause some issues, but we'll leave it for now. We'll leave it like this. I think it'll make it work a lot better. So hopefully you see those subtle things that pop up when you're creating your designs here. And so this is one way of doing it, right? To get this, and then you can offset this, and let's say it could be like plywood, and it could be connected in some way, shape, or form to the floor and to the ceiling. But this is the other way. So this is the simplest way of doing it. And it's extruding it, which we'll have to do anyway. But just unplug this holding down Control. Let me go back to the line segments that are in the way. Now we'll take these and we're going to offset them. So we have to offset them the same as the tread height. So offset curve. Which direction? Well, it's just going to be a distance, because it's going to know that this is the plane that it's on, and we'll offset referencing that plane. Let's go here to distance 6. Now we can take this and this and just loft it together if we wanted to create a surface between them two by grafting them. So using the graft tree. This then can be extruded out. So this is one way of doing it. Okay, I want to show you two different ways of doing this. One is having these two line segments lofted together, which it creates this loft, and then we can extrude again in the negative y direction. So unit y negative, because that's the direction we want to extrude it. And we have to now pick the distance. So in the y direction, we have 12. We actually already had that here, so it's okay. That's one way of doing it. The other way, which is nothing more than taking instead of doing it by lofting these two, you would get the endpoint. And the endpoints of this one create a line segment between the start and the start point, making sure that we graft to make sure that they're correct here. And the same thing here. So we can join the curve between the offset, the original, and the line segments that we just added to create a closed. So I flatten it so it comes in as one long list. And so now that it's been flattened, we have a surface that we can create there. Now this takes longer, but I think it creates a cleaner surface than having to loft them together, because sometimes between these two and these two, you can have issues lofting together. So now with those joined together, so lofting is quicker, but sometimes causes issues. Rather than using an offset curve and two line segments to close them, And so now this gets extruded in this gets joined and extruded in the Y direction. Now let's see. It has to do with the offset. So 6 is wrong, and that's why I see a gap here. The offset has to be the same as the tread height. So 6.5 will be the distance that it gets offset. So 2 different ways of doing it. You pick whichever one you prefer. Sometimes I'd rather take the direction that I know will cause less issues normally than one that's easier that I know will cause issues in some instances. So that's the beauty of parametric design, is different ways of doing the same thing depending on what your outcome is. So what I did here is I started with a basic 3D modeling of doing this. I really wanted to see how this would be created parametrically. And so now we're able to change how wide the stairs are, the length of the tread, how many. So if we have a set of 20 steps, or only 5 steps, we'll go here to 20. This is going to be the offset of how much it goes into. So it could even go back into itself. So 240 is 10 feet. Tread height. Now this offset is determined by the tread height, but you can also make it, let's say if it was going to be just 2 inches deep, it can also be like this. And I think that would also look clean. So depending on what you're trying to do, you can change this up from that to solid. So hopefully you found that useful. This is an exercise in technique in creating stairs. A lot of the techniques we've used before in other scripts, in other stair scripts, but this one gives you an idea of how to create these stairs where these go up, these stay the same, then we create a sweep in between them to kind of join them together. Now let's see if we can, one last thing before we close out, is increasing this slider for the sweep. Now it makes it more subtle. And then 0. So it could actually also be 0. So thank you very much for being here. Hopefully you find that useful. I'll have this available for you guys on my website and in the links below. I post videos like this every week, so if you want to learn parametric design, make advancements in your 3D modeling skills, make sure to follow me here, and I hope to see you on the next one. At the end here, what I'm doing is sharing with you what I did before I created the parametric design. I created it fully inside of Rhino to see how it would work out, and also to keep my Rhino skills sharp. So let me share with you the time lapse of that, and let me know if you have any questions.